what the most surprising thing has been. The most surprising thing has been the lack of public recognition of how close we are to the end of the exponential. To me, it is absolutely wild that, you have people, within the bubble and outside the bubble, but you have people talking about these, just the same tired old hot button political issues and around us we're near the end of the exponential.
I want to understand what that exponential looks like right now, because the first question I asked you when we recorded 3 years ago was, what's up with scaling? Why does it work? And I have a similar question now, but I feel like it's a more complicated question because, at least from the public's point of view,
yes,
3 years ago there were these, well-known public trends where across many orders of magnitude of compute, you could see how the loss improves. And now we have RL scaling, and there's no publicly known scaling law for it. It's not even clear what exactly the story is this supposed to be teaching the model skills? Is it supposed to be teaching meta learning? What is the scaling hypothesis at this point?
Yeah, so I have actually the same hypothesis that I had even all the way back in 2017. So in 2017, I think I talked about it last time, but I wrote a doc called the big blob of compute hypothesis. And it wasn't about the scaling of language models in particular. When I wrote it, GPT-1 had just come out, right? So that was, one among many things, right? There was, back in those days, there was robotics. People tried to work on reasoning as a separate thing from language models. There was scaling of the kind of RL that happened, kind of happened in AlphaGo, and, that happened at Dota at OpenAI, and, people remember StarCraft at DeepMind, the Alpha Star. So it was written as a more general document. And the specific thing I said was the following, that, and, it's very, Rich Sutton put out the bitter lesson a couple years later. But, the hypothesis is basically the same. So what it says is, all the cleverness, all the techniques, all the kind of, we need a new method to do something like that, doesn't matter very much. There are only a few things that matter, and I think I listed 7 of them. One is how much raw compute you have. The other is the quantity of data that you have. Then the third is kind of the quality and distribution of data, right? It needs to be a broad distribution of data. The fourth is, I think, how long you train for. The fifth is you need an objective function that can scale to the moon. So the pre-training objective function is one such objective function, right? Another objective function is, the kind of RL objective function that says, you have a goal, you're going to go out and reach the goal. Within that, of course, there's objective rewards, like you see in math and coding, and there's more subjective rewards like you see in RL from human feedback, or kind of higher order versions of that. And then the 6th and 7th were things around kind of normalization or conditioning, just getting the numerical stability so that kind of the big blob of compute flows in this laminar way instead of running into problems. So that was the hypothesis, and it's a hypothesis I still hold. I don't think I've seen very much that is not in line with that hypothesis. And so the pre-training scaling laws were one example of kind of what we see there. And indeed, those have continued going. I think now it's been widely reported, we feel good about pre-training. Pre-training is continuing to give us gains. What has changed is that now we're also seeing the same thing for RL, right? So we're seeing a pre-training phase, and then we're seeing an RL phase on top of that. And with RL, it's actually just the same. Even other companies have published in some of their releases have published things that say, look, we train the model on math contests, AIME or the kind of other things, and how well the model does is log linear in how long we've trained it. And we see that as well. And it's not just math contests, it's a wide variety of RL tasks. And so we're seeing the same scaling in RL that we saw for pre-training.
You mentioned Richard Sutton and the bitter lesson.
Yeah.
I interviewed him last year, and he is actually very non-LLM pilled. And I don't know if this is his perspective, but one way to paraphrase this objection is something like, look, something which possesses the true core of human learning would not require all these billions of dollars of data and compute and these bespoke environments to learn how to use Excel or how to use PowerPoint, how to navigate a web browser. And the fact that we have to build in these skills using these RL environments hints that we're actually lacking this core human learning algorithm. And so we're scaling the wrong thing. And so, yeah, that does raise the question, why are we doing all this RL scaling if we do think there's something that's going to be human-like in its ability to learn on the fly?
Yeah. So I think this kind of puts together several things that should be kind of thought of differently.
Yeah.
I think there is a genuine puzzle here, but it may not matter. In fact, I would guess it probably doesn't matter. So let's take the RL out of it for a second, because I actually think RL, and it's a red herring to say that RL is any different from pre-training in this matter. So if we look at pre-training scaling, it was very interesting. Back in 2017, when Alec Radford was doing GPT-1, if you look at the models before GPT-1, they were trained on these data sets that didn't represent a wide, distribution of text, right? You had these very standard, kind of language modeling benchmarks. And GPT-1 itself was trained on a bunch of, I think it was fan fiction, actually. But, it was like literary, it was like literary text, which is a very small fraction of the text that you get. And what we found with that, and in those days it was like 1 billion words or something. So small data sets and represented a pretty narrow distribution, right? Like a narrow...